Hi everyone, my name is Thomas Kim. Today is April 16th, 2023. Open up Visual Studio Code, Electricity and Magnetism. Click this button, 047, Uniform Block. Click this button, Cube Butt. Click this button, Cube Crack. Click this button, Cube.cpp. Click this button, resp.txt. Hit enter. Ctrl B. I will close welcome window in the queue.cpp. I will copy and paste these links. In this episode, we will learn interface blocks, uniform blocks, primitive restart, MapBuffer, glBindBufferBase. These things are explained in this book, OpenGL Survival 7th edition. For restart primitives, please watch this video. In episode 92, OpenGL Rotating Q2, restart primitives, triangle strips, Vertex indices. In this episode, I explained how to use restart primitive. I filmed this video on October 25th, 2020, over 2 years ago. If you haven't watched this video, you may have difficulties understanding restart primitives. Now I will hold it up. Include CPG, STD extensions. Include OpenGL Survival7.hpp. To use OpenGL Survival7.hpp, I assume you have watched my previous videos listed here. In episode 34, we installed Visual Studio, then NVIDIA CUDA, OpenGL C++ headers. In episode 35, we installed OpenGL tools. I provide all the required tools through these links. For example, OpenGL Survival 7 tools. If you haven't installed these tools, you may not be able to follow my current session. I will fold it up once again. Class public SB7 application semicolon declare main. We provide this class name here. Int main auto h instance get module handle null win main h instance null sw show. Now I will open this command prompt. You should see Intel Cycle OpenGL Survival 7th edition. This command prompt string dir cd 047 uniform block icx cl cube.cpp oi.exe qsdd C++20 don't miss ehsc md debug build link subsystem console. Hit enter. You should be able to build successfully. Now copy this string. Copy. I will paste it here. Also in the response file, paste it here. Now we can delete this part. We will use icx cl cube.cpp at resp.txt. We are using response file cls I. You should be able to see this window, then this console message. Now we close response.txt. I will arrange shaders side by side. This is Vertex shader. This is fragment shader. Version 460 core. Copy this. Paste it here. Now in backport position. This is Vertex attribute array out vs out. We make a block vs out. This is called interface block. This block has member backport color. Copy this, paste it here. This is input. I will rename fs in. vs out. This is interface block name. Lowercase vs out. This is instance. vs stands for vertex shader. In the fragment shader, vs out is interface block name. fs stands for fragment shader. Here, out backport color. Void main color. This is output color. fs in has member color. Now layout std 140 uniform transform block transforms map4 MB stands for model view matrix. map4 projection matrix. This is called uniform block. I will copy these things. If you control click, you can read more about interface block. If you scroll down, you can find memory layout. We are using std 140 for uniform block. std 140. Here we can also find std 430. Note that this layout can only be used with a shader storage block, not uniform block. We cannot use std 430 for uniform block. std 430 can only be used with a shader storage block. We will learn shader storage block in my next episode. Now void main GL position. This transform block has member projection matrix times the transform model view matrix times the position. Then backport color offset. Backport 1.0, 1.0, 1.0, 0.0. From vs out has member color. We assign output color position plus color offset. We are transferring position plus color offset to fragment shader through fsin.color. Now I will close cube.frag, then arrange like this. In the class cube public using base. This is our base class. Static glUint load shaders. gl unsigned int vertex shader sb7 shader load. We provide cube but gl vertex shader. Copy paste. This is fragment shader. Cube.frag gl fragment shader. Right click, load, go to definition. In this file, file name is loaded. Then it creates shader and compile the shader. This function load returns compiled shader. Now GL unsigned int program, GL create program, semicolon, GL attach shader, program Vertex shader, GL attach shader, program fragment shader. Now GL link program, GL delete shader, Vertex shader, GL delete shader, fragment shader, return program. Now private GL unsigned int program, public, right click, application, go to definition. If you scroll down, you can find virtual member function. I will copy from startup up to on resize. Copy, then paste it here. I will close this header file. Now override, copy, paste, paste. I will delete set window title. Now we remove virtual. Actually, this optional. Virtual is optional. I will simply remove to make my code look clean. In the function on resize, std cout on resize called cbg, and there we rebuild clsi. We cannot see on resize called message, so in the startup we call on resize. We pass base info window width, base info window height. With this, we close this window, then rebuild clsi. Now we can see on resize called message. Now close it. Scroll down, we will disable it. Then base on resize, we pass wh. If w greater than h, gl viewport w minus h over 2 0, the smaller h, else gl viewport 0 h minus w over 2 w. Here sed cout w h cpg, and there we rebuild clsi. Now we can see w is 800, h is 600 by default. Now close it. Scroll up. In the function startup, program load shaders. We defined this program here. I will create a block. I will copy and paste in this block. These are 8 vertices representing a cube. These are indices of the vertices of our cube. Through 2 videos, episode 92-91, I created these vertices for our cube. If you control-click this link in this video, show more, download source code. If you click this link, show in folder, unzip it. Then in this folder, restart primitive. If you open this file, you can find these things. Please understand, I created these vertices and indices for a cube through these two videos. Now, here, vertex positions assign. I haven't created vertex positions yet. Scroll up. In the private section, std vector gl plot vertex positions std vector gl ushot unsigned shot vertex indices. I declared two vectors. Now scroll down. We will initialize vertex position using member function assign. std begin. We pass vertex position array. std end. We pass vertex position array. Vertex indices assign. std begin. We pass vertex indices array. std end. Vertex indices array. Now std cout vertex positions cpg and there copy paste vertex indices. With this we build again cls I. Now in the command prompt you can see vertex position and the vertex indices. Please notice this number 65, 53, 5. This number represents GL unsigned shot -1. The type of these vertex indices are GL unsigned shot. If you do not know how to use vertex indices, please watch these two videos. Now I will close it. I will disable these. Then fold it up. We initialized vertex positions and indices for our cube. We need location for position. Vertex attribute called position location gl get attribute location. We pass program, then this position name as a string, semicolon, copy, paste. We need to get the position of this transform location. We use gl get uniform location. We pass transform as a string. Of course, we have to define position location, transform location in the private section. gl int position location, gl int transform location. Now here to feed our vertex attribute position, we have to create vertex array. gl create vertex array. One vertex array object. gl bind vertex array. This vertex array should be found. Create vertex arrays, bind the vertex array. We haven't defined this variable yet. gl unsigned int vertex array object. Now scroll down. Here we will create 3 buffers for position of our vertices. for our cube. Also buffer for vertex indices. Also buffer for transform block. Here gl unsigned int position buffer, gl unsigned int indices buffer, gl unsigned int transform buffer. I made typo here. Now scroll down. We will create 3 buffers. Create and initialize. Buffer for vertex positions. gl create buffers. 1 position buffer. gl bind buffer. gl array buffer. We pass position buffer here. gl buffer data. gl array buffer. We pass size. Vertex positions size. It should be byte count. So size of gl float. Then data. Vertex position data. Usage gl static draw. It should be plural. Now create and initialize buffer for vertex indices. I missed T here. gl create buffers. 1 indices buffer. gl bind buffer. gl array buffer. We pass indices buffer, but we will use this buffer to hold indices. So it should be element array buffer. gl buffer data. Target. Target should be gl element array buffer. Size. Indices. No. We have to use vertex indices. Here vertex indices size times size of gl unsigned short. Then data. Vertex indices data. Usage gl static draw. Now create an uninitialized buffer for uniform transform block. We are creating a buffer for transform block. gl create buffers. 1 transform buffer. gl bind buffer. We use gl uniform buffer transform buffer. gl buffer data. Target. Target is gl uniform buffer. Then size. This buffer contains 2 mat4. So 2 times size of mat4. This is 1. We mass mat4. This is correct. Then data. We create an initialized buffer. So null. Usage gl dynamic draw. Scroll up. We need to specify vertex attribute pointer for position like this. gl vertex attribute pointer position location GL int size. Our vertex position array has 4 elements for each vertex, so we specify 4 type: GL float, normalized, GL pulse, stride, 0 pointer. This is offset. Null. GL enable vertex attribute array position location. Now GL enable GL call face, GL call face, GL back, GL front face, GL counterclockwise direction. These are actually default values. GL enable GL depth test, GL depth function, GL less or equal, GL enable GL blend, GL blend function, GL src alpha, GL 1 minus src alpha. Now in the function render static constant GL float green. This is erase color 0.0f, 0.25f, 0.0f, 1.0f. Static constant GL float 1, 1.0f, GL clear buffer FB, GL color 0 green, GL clear buffer FB, GL depth 0 1. We clear background color with green. We clear depth buffer with 1.0. Now GL use program. Now GL uniform block binding program transform location transform binding. GL unsigned int transform binding I will set 0. Then GL bind buffer base, GL uniform buffer transform binding transform buffer. About GL uniform block binding, please refer to this document. About BindBufferBase, refer to this document. Plot f plot current time times 0.3 f. vmath mat4 pointer transforms GL MapBuffer range. Target should be GL uniform buffer offset 0 size. In this uniform, we have two elements of type mat4, 2 times size of vmath mat4. Access GL map write bit, GL map invalidate buffer bit. For more information about MapBufferRange, please refer to this documentation. We need typecast vmath mat4. Now transform 0. This transform 0 represent model view matrix. I will simply copy and paste. Transform 1. This transforms 1 represent projection matrix. I will copy and paste like this. Now GL glMapBuffer, glUniformBuffer. Scroll down, glEnable, glPrimitive restart, semicolon, glPrimitive restart index, glUnsigned short, -1, glDraw elements, glTriangle strip, count, Vertex, Indices, size, type, glUnsigned short, indices. This represents offset. We will simply pass null. About primitive restart, please refer to these videos. In these videos, I explained how to use primitive restart. Now, I will remove blank space. Scroll up, copy these things. Scroll down, paste it in the function shutdown. After use, we have to delete delete program. I will delete this. Delete vertex arrays. 1. Copy this, paste it here. I will delete this. Delete buffers. 1. Position buffer deleted. Copy, paste. Indices buffer is now deleted. Copy, paste. Transform buffer is now deleted. We will remove this part. In the command prompt, we rebuild CLSI. So, this is our result. Now, close it. Please understand that my primary goal of this video is understand how to use uniform block. In this uniform block specification, we haven't used binding qualifier. I will copy, disable it, then paste. Here, binding, I set 2. Now, scroll up. In this part, we set transform binding. This transform binding is used in 2 places. Uniform block binding. In this function, we passed transform binding. In the glBindBufferBase, we used transform binding. Now we set binding 2. I will change it to 2. Then I can disable it. With this, we build again. CLSI. It works perfectly. Now, close it. Also, in this document, Control-click Interface Block. If you scroll down, you can find memory layout. Here, STD 430. We will try STD 430. We build again. CLSI. It does not work. Now close it. Because this documentation says this qualifier. Note that this layout can only be used with a shader storage block, not for uniform blocks. So I will restore it back. Remember, 140. With this, we build again. It works correctly.